Hey there, geometry. We are in Unit 1. We're moving into Lesson 12, which is defining translations. Actually, I'm going to go over here to Cami, where I've already done a few things. But let's talk through this notice and wonder, okay? What do you notice? What do you wonder? If I look right here, I notice a triangle and another triangle and a vector v, which we can say is a vector of translation. We write vectors using this form right here, v with a one-sided arrow on top of it. Oh, my face is missing. That's hilarious. We can say that CDE in blue is called the pre-image, and we move that, we translate it along this vector, and it becomes the image. And notice we have primes to label the vertexes of the triangle and the image. C goes to C prime, D goes to D prime, E goes to E prime. We go from the pre-image to the image. Translations can also be called slides. Okay, you may see that terminology. It's another way to describe what we're doing. The other thing I want you to know is this vector V, so from here to there, that's a specific length. This is not a willy-nilly ray being drawn. A ray actually goes on forever in the arrowed direction. It starts at an end and it goes forever in the arrowed direction. A vector has a specific length and a direction. If you liked the movie Despicable Me when you were younger, they had the villain Vector, and he would say, what would he say, like force with direction or magnitude with direction? I don't know. Excuse me, it always made me laugh, but that's what we're talking about here. All right, let's go into our first example. What's the point? Translations. So student task statement. After translation, the image of V is W. Write at least 3 other points that are taken to a labeled point by that translation. What I did here is, the first time I did it, let's go for, all right, so we're going to go V to W. Okay, what's really cool is I'm going to drag this along and we'll see. Oh, yeah. So I can actually match this up and I can say L goes to I, K goes to G, J goes to E, G goes to B. I'm measuring in a direction and a length. All of these points are all translations. If they match up with my endpoints of what I'm moving around, they're translations. Those are all connected. All right, let me see. There was just one more thing I wanted to show you or tell you about in this section. After translation, the image V is W. Find at least 3 other points that are taken to a labeled point by that translation. We can actually do that. I'm not sure if we can do that here. Nope. If we were in GeoGebra, I would draw a circle from V to W, and I would take that center V and drag it everywhere to see if it were the same length, because that could be considered a radius. Okay, so that's pretty cool there. Now it says, write at least one conjecture about translations. Translations take lines to parallel lines. Directed line segments form parallel lines. And what I want to show you here is the teacher's manual. So we see right here that V goes to W, and we drug that vector around everywhere and showed that I can do a segment, C to A, I to E, L to J, Q to M, and those are all parallel to each other. Okay, it's pretty cool. I think the next part tells us to, in a new translation, the image of V is Z. So we actually can take the image of V going to Z, which is going to be down here. See, here we have V going to Z, which if I picked this up and moved it around, which I believe I can do, yep, let's grab this. This was V going to Z, and I could drag it everywhere, W to Y, whatever those letters are, right? I'm sort of, there we go. So I can drag it everywhere it goes, as long as it matches, and show you that those are also parallel lines. So VZ and WY are parallel, okay? HR and DN are parallel. I can connect H to D and R to N and make 2 more parallel lines. Looks kind of like a parallelogram, which is very cool. Okay, and what else did I want to tell you here? I think that was it. Are your conjectures still true? Yes, they are still true. Okay, let's go into the student translation. I should have gotten a new one here. Sorry. These instructions tell us to translate triangle ABC along vector AC. Is that how it says it? I want to make sure I get my wording correct. Translate triangle ABC by the directed line segment from A to C. So I'm actually going to draw that vector. I can click here and get my vector tool and go from A to C. Now I can actually get this vector tool, which I can select this figure, select the vector, and it will translate it for me. And it translated it in a very specific length. So I think, is this my measurement tool? No. Distance or length. So we can actually measure AC and measure A prime C prime, and we see that they're exactly the same measurement, and that makes sense. AB and A prime B prime, same measurement. It was a rigid motion, so we did not change the length of AB at all. And then BC, can't really see there. I can drag this up. Nope. And B prime, C prime, exact same measurement. So I think it says, what is the relationship between BC and B prime, C prime? They're congruent. They're the exactly same measurement, and they're parallel. Okay, they're parallel to each other. How does the length of the segment BC compare to the length of segment B prime, C prime? They're congruent. I already said that, sorry. Because it's a rigid motion. Okay, now translate segment DE by directed line segment W. Label the new endpoints D prime and E prime. Okay, we're going to do this the simple way through GeoGebra, and then I'm actually going to show you how to do this by hand using a compass. So if I click that, I can translate the vector by selecting the object and the vector, and it's going to translate it for me. Now I'm going to actually do this by hand too. So what's really cool is the distance from D to D prime is the same as the distance from E to E prime, which I can use a circle to do that. If I get an endpoint of W of this vector, this directed line segment, and use those endpoints to measure a circle, and put that circle at D, we see that D prime is there. I'm going to ignore that for now because I want to show that happens on my own. I want to do it again because I would like to show that E is going to move the exact same amount. See that? But we're not done. If we were doing this by hand, we wouldn't have D prime and E prime there. So now I actually want to show that the distance from the beginning of the vector to D is going to be the same as the end of the vector to D. So if I measure a circle here and put it there, we see that that is where D prime is. The intersection of the circle centered at D and the circle centered at this dot are the same. If we do that again, the circle centered there, and we move it here, so the distance from the beginning of the vector to the end of the vector are the same, and that is where this intersection is. So I can draw a segment from this intersection of circles to that intersection of circles, and I get my translated line segment. And the other thing that we want to do here is connect D to D prime and E to E prime. Would actually make better sense if we did this, because then you could see it a little bit better. What have we drawn here? It's a parallelogram. Opposite sides are parallel and the exact same measurement. These sides are parallel and the exact same measurement. So we have a parallelogram there. Properties are opposite sides are congruent and parallel for a parallelogram. All right, if you look in your summary, it goes through everything we've talked about today, and our glossary is all updated. That's it. Good job.